of particles. Kinematics of particles, about geometry of motions. Geometry. ጂኦሜትሪ ኦፍ ሞሽን እንግዲህ የሞሽኖች ወይም የእንቅስቃሴዎች ጂኦሜትሪ ወይም ዳይሜንሽናል የሆነ ዳይሬክሽናል የሆነ ሙቭመንት ነው ብዙውን ጊዜ የምናየው ማለት ነው። ሶ ኢት ኢዝ ኦል አባውት አክሲለሬሽን፣ ኢት ኢዝ ኦል አባውት displacement, it is all about velocity, and it is all about acceleration, and it is all about the acceleration, velocity, and in terms of time. These relationships are all encountered and all included here in kinematics of particles. It is all about the geometry of motions, which relates these things, which relates these basic parameters, and it is all the indications without reference to the cause of the motion. እንግዲህ የሞሽኑ መነሻ ወይም cause of motion without considerations to cause of emotion. ያ ኪኔማቲክስ ዋና ለየት የሚያደርገው ምንድነው? የዲስፕሌስመንት፣ ቬሎሲቲ፣ አክሲለሬሽን እና ታይም of an object or an object in a motion, of a particle in a motion without considering the cause of the motion. እንግዲህ የሞሽኑ መነሻውን የሱ ቦዘር አይደለም ማለት ነው። የሞሽኑ መነሻው it is not bothers about, it is not the issue for kinematics, but the motion of the particle itself is the issue for kinematics. Kinematics is not considering the cause of the motion, but it considers particles in motion. What about the types of motions here in kinematics? Kinematics ላይ ያሉ parts of motion deal ስናደርግ about plenty of motions are there. We can deal about the rectilinear motions, motion in a straight line at a constant speed. We can deal about rectilinear motion, rectilinear motion, okay? Rectilinear motion, linear here in linear, in straight path, okay? In straight path, for example, take it a car, okay? You can consider a car moving in a straight line, okay? We can consider a car moving in a straight line at a constant speed, straight line. This is all about the rectilinear motion. So what about curvilinear motions? We can deal about the curvilinear motions, rectilinear motions, projectile motions here. So these all are the motions categories which are to be dealt with kinematics. እንግዲህ ሬክቲሊኒየር ብለን ስናወራ በቀጥተኛ መስመር ላይ ያለውን አት ኮንስታንት ስፒድ የሚሄደውን አንድ ፓርቲክል ሞሽን ኮንሲደር ያደርጋል ማለት ነው። motion of particles, motion in a sense, displacement of particles, and velocity of particles, acceleration of particles. We will be plenty of problems on this. እንግዲህ የተለያዩ ፕሮብሌሞችን ኤግዛምፕሎችንም ጭምር እንሰራቸዋለን እዚህ ጋር። and time is there, change in displacement, change in velocity, rate of change of acceleration, velocity is there, acceleration, okay, and the change of time is there. So when you come about rectilinear motions also, we have plenty of terms to focus about. Specifically, let's say the position. We'll deal about specifically position. What's the position of a particle? Position. The motion is there means in motion there is a position, okay? There is a position. So if a body is in a motion means there is some point position you can consider. For example, maybe the destination or the some reference point. Maybe some origin point may be taken as a reference point. Let it say origin, and there is a particle or position or destination, maybe some reference points that you can consider for your measurements of velocity, acceleration related to time, okay? When you deal about position, it is measured and recorded with plus or minus sign. እንግዲህ በማይነስ እና በፕላስ ሊመታ ይችላል። ሳይኖች ሊመታ ይችላል። ለምን ፕላስ ሊመታ ይችላል? ሜቢ we have coordinates of positive coordinates and negative coordinates to indicate a direction. That is why I am talking about left and right, your hand, okay, left and right to some reference position, So according to these positions, directions, so position can be indicated as to the left or to the right. Just it is to say by minus a plus, okay, minus n plus. This is not all about the loan and something and extra ordinary indication, but just plus and minus signs are to indicate the direction of a position of a single particle. Yeah, from origin, okay. So when you deal about position, for example, I will give you some position indicator. Let's say origin O. Let's say origin O, and this is a reference point for you. And there exists a P particle. P particle after S distance apart from the origin. S distance apart from the origin. So the gap between the origin and the position of the particle is called distance. This is called distance. Okay, distance. And so a distance is just a scalar quantity, just indicates the unit of the magnitude, okay, magnitude of the length of the path, okay. This is a path. This is a path from this to this position. So this length in unit of measurement is just distance, maybe in meter, maybe millimeter, kilometer, and like that. Okay, so basically as SI unit you can consider distance as meter, So this is a basic term to indicate about distance. When you deal about the displacement, there exists some change of position coordinate, okay, change of position of a coordinate. So change of coordinate, the distance also may change this particle. Since we are dealing about the motion, so we can deal about change of motions of the position of the motion, change of position of the position of the an object. For example, let's say if this particle changes position from its original position to P, we can say as P prime to indicate the copy of it one, the copy of the original. So it will change. The distance will also change, right? The distance will also change. This is a change in distance. This change in distance is there. So the distance from the origin to this one is the S prime, you can say S prime, like as we said P prime. So S prime, you can say. So the magnitude of the length between the P and P prime in changing S. This changing S is equals to S prime minus S. Okay, S prime minus S. This is change of a position. That's measured by a distance. So distance traveled should not be confused, okay, with displacement that I told you before. But distance is just a scalar quantity which represents the length of the path, I say, okay, the length of the path. Whereas displacement is a vector quantity, I said, vector quantity. So you can take these things in consideration. Now it's on. We can talk about the time, okay. እንግዲህ ስለ ታይም ስናወራ ደግሞ አሁን ምንድነው ስለ ታይም ስናወራ አንድ ኦብጀክት እንቅስቃሴ ላይ ያለ መጀመሪያ ላይ እዚህ ፖዚሽን ላይ ያለ እዚህ ፖዚሽን ላይ ያለ from some reference position to measure እዚህ ፖዚሽን ላይ ያለ p ነው ብለናል. P is this particle, position of the particle just. But it takes some time to travel from the position P to P prime. እንግዲህ ከP ወደ P prime በሚሄድበት ጊዜ ሞሽን ስለሆነ እንቅስቃሴ ስለሆነ እያወራን ያለ ነው። እንቅስቃሴ ስለሆነ ምን አለ change of time is there, okay, change of time. It takes time to travel from this position to this position, right? There exists a change of time. So there exists change of time. Here is some time is there for a particle to stay at here from its reference position after some distance changing s apart. There also exists t plus changing t. እንግዲህ መጀመሪያ ላይ t ወስዶ ከሆነ ሪፈረንሱ ከ0 ፖይንቱ ወደ p ሄደው ከp ደግሞ ወደ p ፕራይም እስኪሄድ ድረስ ደግሞ ምን አለ it adds a time interval difference called change in t. There exists change in t. So depending on this p of the position where it deal about the particle p is moving. Depending on this, we can deal about velocity. Now it comes velocity. velocity it comes. Velocity it comes. Velocity. What's velocity? Velocity is the rate of change of displacement, right? If there exists a smaller smaller values of change in t, smaller and smaller values of change in t, when it comes to change in t, there exists magnitude of change in s. Okay, magnitude of this change in s becomes what? Smaller, and consequently the instantaneous velocity of the particle becomes what? T obtained as what? ሊሚት just as t ይሄኛው t smaller amount of change in t ከሆነ እየሄደ ያለው smaller amount of change in t ከሆነ እየሄደ ያለው velocity is equals to limit as change in t approach to zero change in s over change in t. Change in s v becomes v is equals to what? Positive when or if and only if change in t is equals to change in s is equals to ፖዚቲቭ ቼንጅ ኢን ኤስ ኢዝ ኢኳልስ ቱ ፖዚቲቭ። ስለዚህ ቼንጅ ኢን ኤስ ፖዚቲቭ በሚሆንበት ጊዜ ኦር ኤስ ዲስፕሌስመንት ፖዚቲቭ በሚሆን ጊዜ the velocity becomes positive, whereas velocity becomes negative when change in s becomes negative. Change in s becomes negative. V is equals to negative when s is or change in s is equals to negative. So change in s negative በሚሆንበት ጊዜ v negative ይሆናል ማለት ነው። So relation is like this. When you come up to acceleration also, acceleration is equals to dv by dt. We can talk about that acceleration. Okay, acceleration. ስለ acceleration ደግሞ ስናወራ እንዴት ነው? Just gt is about velocity. We can talk velocity. Acceleration is equals to velocity over time, right? V over time. Velocity over time. We know this. So acceleration can either be positive or negative. It depends on velocity. So acceleration is equals to vt. Now when we deal about the rate of change or smaller increase or decrease, we can talk about the differential. We can make differential because it is incrementally or in small amounts. It is increasing or decreasing in small amount. So acceleration is equals to dv by dt. We can consider. So when you come to v is equals to ds by dt. Smaller amount of change in time. So now we can substitute and come up with acceleration. Acceleration is equals to differential of ds by dt is all divided by dt. We can make. So it becomes acceleration is equals to a square, differential square, not a square. Differential, that means twice differentiation of s over d square or dt square. Formally it is written dt square. This is second derivative. Okay, second derivative of s becomes what? Acceleration. Agree? ሁለት ጊዜ acceleration the displacement derivate ስናደርግ acceleration እንደምናገኝ ነው። አንድ derivate ስናደርግ ደግሞ ስንት ነው እንደምናደርገው? velocity እናገኛለን ማለት ነው። It becomes here it comes velocity is equals to ds by dt. We have seen. Okay, this is the first differential of s. It became what? Velocity. እንግዲህ velocity የሆነው ማለት ነው the first differential of s. When it comes here, it is the second differential of s becomes what? Acceleration. This is concept. Acceleration. Rate of change of displacement is